So new booklet ka page 47. Let's have a look at this question from discrete random variable. The random variable x takes each of the values 1, 2, 3, and 4 with probability 1 over 4. That means the probability for every value occurring is the same. Two independent values of x are chosen. We have been doing such questions with different dice and other different spinners or things like that. But here they have not given us an apparatus, but they've just named the four values that x may take. Two independent values of x are chosen at random. If the two values of x are the same, the random variable y takes that value. Otherwise, the value of y is the larger value of x minus the smaller value of x. And now what should we do to analyze this entire thing? Very good. We should make a possibility diagram for this one to help us understand and eventually draw the probability distribution table. So I believe this is the kind of possibility diagram that you can make. If x takes the values 1, 2, 3, 4, and the second value of x again can be 1, 2, 3, 4. So if both values of x are taken as 1, we will note down y as 1. If one of them is taken as 2 and the other one is 1, we will write y as 1. Again, why? Because the larger value of x is 2 minus the smaller value of x is 1. Sahi hai? So let's fill out this entire possibility diagram. Done. If I take 3 as one number, the first value of x is 3 and the second value of x is 2, what should I note down? I'll subtract the larger value minus the smaller value. That will be 1. Now, this is just to help us make the probability distribution table. Now, these are the values of y. Now, what are the values that my y is taking? It's either taking 1, 2, 3, or 4. Now, make a probability distribution table. What is the probability that I get the value y as 1? 6 over 16. First, this is how the probability distribution table must look like. Say yeah. So the value that my discrete random variable takes is 1, 2, 3, and 4. And the probability of 1 is 7 over 16, right? 6 or 7? 1, 2, 3, 4, 5, 6, 7. Count karo. 7 over 16. For 2 it is 5 over 16. For 3 it is. And for 4 it is. Now the question is telling me find the probability that y is 2. Given that y is even, this is a conditional probability question. So in the denominator, I'll write the probability of y being even. What is the probability that y is even? 6 over 16. And the numerator, the probability of getting a 2, which is 5 over. Another way, once I have the possibility diagram, can you tell me how many even numbers are possible? How many even numbers are possible? 6. And out of those, how many are 2s? 5 are 2s. We could have directly done it 5 over 6 as well. दोनों तरीके हैं count करके भी. Once you have the number, you could have directly done it with the quantity as well. But if you do not have the quantity, you could have done it through the conditional probability as well. Now let's have a look at another question. New booklet, page number 77. Read the question. Give it a go. So the first part says x is the values that the variable can take, which is 1, 2, 3, 4. You can simply plug in the values of x and find our probabilities. So the probability that x is 1 is 4k, 2 it is 6k, for 3 it is 6k, and for 4 it is again 4k. Is that the case? So yeah, then the part says show that the variance is 1.05. We cannot find the variance until and unless we find the value of k. How do we find the value of k? How do we find the value of k? K is just one unknown. So your target should be to just make one equation which should involve k. Very good. All the probabilities will add up to be 1. 4k plus 6k plus 6k plus 4k should be equal to 1. Find the value of k. Once you have the value of k, you will have all the probabilities. K is 20. K is 1 upon 20. Now you can use the value of k to write down all the probabilities and find the variance. Now there are two ways of doing it. Either use the value of k and figure out the probabilities and then use them. I've directly used it. You can separately find expectation first. That will make things easy for you. Or you can find everything in terms of k first and then plug in the value of k at the end. So yeah, both ways of doing it. Dono mein you will have to go through multiple steps. Yes, but find the expectation separately first. I've done it in a single step, but I want you to find the expectation, either the expression for expectation or the value for expectation using the value of k. Zara, booklet page 178. A box contains 6 identical sized discs, of which 4 are blue and 2 are red. Discs are taken at random from the box in turn and not replaced. Let x be the number of discs taken up to and including the first blue one. So you're taking out discs until you get the first blue one. How will we understand this one? Very good. We can make a tree diagram to understand that the first one will either be a red one or a blue one. Now, what is the probability of getting a blue one? 4/6, and red is 2/6. Obviously, we're just making it to help us understand the probability. Red is 2/6, and this is 4/6. If we take the first blue one out, then we do not take any other discs out. But if it is a red one, then we again take another disc out, and the probability of that being red is 1/5. And the probability of that one being blue is grow up. Why 2/5? What is the probability of the second one being blue? Understand the tree diagram. If you take the first one out is red, if the first one that you take out is red, then the second one will be either red or blue. Now, how many reds remain? Out of 5. And how many blue remain? 4 out of 5. If the second one is blue, then I do not take any other disc out. But if it is red, then I again take out another disc. And obviously, then I am done with red. So the probability of getting a red is 0. And the probability of getting a Blue is 1. Now understand what your discrete random variable is in this question. In this question, our discrete random variable is the number of disks that we take out until we get the first blue disk. We have to comprehend it ourselves by reading the question. Is that clear? So the first part says probability x is equals to 3. What does that mean? What does this notation mean? Probability x. Yes, the third disk taken out is the first blue one. So which path should we follow? Very good. The first is red and the second is red and the third is blue. So what is the value? Yes, so 1/50. The next part asks you to make the probability distribution, asks you to draw the probability distribution table for x. Now, what possible values can the x take? X can either be 1, x can either be 1, or it will be 2, or it will be 3. Third में तो लाजमी either way I will get the blue disk. उसके बाद I do not need to take out any other disks. So x can only take 3 values, 1, 2, or 3. So draw a probability distribution table using the tree. So x is equals to 1 when the first one is blue. Its probability already you can see from the tree, that is 4/6. You already know the probability for x equals to 3. You can add these two and subtract the value from 1 to get the value of probability x equals to 2. Or you can also find this value through the tree as well when the first one is red and the second one is blue. Either ways, you get the same value. This is your probability distribution table for this particular question. Okay. Let's have a look at another question. New booklet, page 214. First, try to understand the question on your own and try to attempt it, and then I'll guide you. This can happen in many ways. 1, 1, and 2. The two spinners land on 1 and one of these spinner lands on 2. And what is the probability of that? 1/4 into 1/4 and 1/4. And this can happen in any order. Is that right? So what is the possible order for these three? 3 factorial divided by why 2 factorial? Because 2 ones are identical. इसी तरीके से this can happen with 1, 2, 2 as well. You'll still record x as 2. And again, the probability of that happening is 1/4 into 1/4 into 1/4. And how many orders can this exist in? 3 factorial divided by 2 factorial. This could have also happened when you would have got 2 on all 3, 2, 2, 2. And the probability of that happening is 1/4 into 1/4 into 1/4. Add all of them together. Tell me, what do you get? Write it down. The next question is page 1. Page 121 of old booklet. Okay, one way of doing this question was either through a probability tree. Another way is we could have also used combinations. So yeah. If we were doing it with combinations, we could have said 3C1, so 3 out of 1 shirt, 9C2, any 2 non-t-shirts, and 12C3 are the total possible combinations. Write it through both ways. Another way of doing it was using the probability tree, in which we would have said t-shirt, not t-shirt, and not t-shirt. And that could have happened in any possible order. Now, if you were to draw a probability distribution table for this one, what possible values can my X take? Yes, 1, 2. Can I also get 0 t-shirts? Is it possible if I selected 3, none of them might have been a t-shirt? So 0, 1, 2, and 3. Is that right? Okay. We have already figured out the probability of 1, and that is 27 over 55. Is that right? What about 0 t-shirts? तीनों ही नॉन टी शर्ट आ गई मेरे पास. We could use combinations as well. 9C3 divided by 12C3. Or not t-shirt, not t-shirt, not t-shirt. 9 into 9 over 11 into 8 over 10 into 7 over 9. Hmm? 21 over 55. I've given you the hint. Whenever you want to draw a probability distribution table, always try to fill it from the extremes, from the left and the rightmost, and then come into the middle one by one. So पहले come to 3. अब 3 को पहले fill करो. 3 t-shirts. 3C3 upon 12C3, or 3 over 12 into 2 over 11 into 1 over 10. So 3 t-shirt. What is the probability that I get all 3 t-shirts? That is one way, and another way is 3C3 upon 12C3. अब पे आ रहा है 1 over 220. So now you have all these 3 values. You can add them up, subtract it from 1, and tell me what do you get? 27 over 220. Two C. 27 over 220. So this is how we can draw this probability distribution table.